This video is an introduction to the calibration of the Correlated Solutions VIC 3D system. We're assuming that you have a good camera set up here and that the cameras will no longer move. I really can't stress this enough. From here on out, if you so much as sneeze on the cameras, you're basically restarting the calibration process. There's a range of different calibration plates available depending on what size target you're planning on measuring. The rule of thumb here is to choose a plate which easily fits in the field of view of your camera at the same distance as your specimen. For example, this one here would be too large, whereas this one here would be too small. This one would be perfect. I'm going to outline two different methods of calibrating. The first method works 90% of the time, whereas the second method is only really needed for setups where the available calibration plate is too small or can't easily be seen by both cameras simultaneously. For starters, we need to know which calibration plate we've chosen. This one's the 12mm plate. You'll find that all of the plates are labelled on the back. Next, as the plates are likely shinier than the surface that you're going to measure, you will need to adjust the brightness of your lights to compensate. Keep your calibration plate in position at the focal plane and adjust accordingly. This is a little bit inexact, I'm afraid, but I believe it's better to err slightly on the side of too bright than too dark. There are two main capture modes that we need to know about at this point. The first and probably most handy is the timed capture mode here. Press start and it will take an image every, in this case, 500 milliseconds, but this can be adjusted to be whatever you want. The second is to manually capture by pressing the capture button here. Pressing the spacebar will also do this. After hitting start for time capture, the procedure here is to get the cameras capturing images while we rotate the calibration plate around all three axes. Be careful to move slowly enough so that we don't get motion blur, and pay close attention to the three special dots on the plate, as we don't want those dots to fall off the images of either the left or the right cameras. Stop capturing when you've done all of your rotations. Ideally, you'll have in the vicinity of about 100 images taken when you're all done. Next, we're going to take a few images of the specimen itself. This is an optional extra part of the calibration procedure, but we'll need to get the lighting right again first. Put the software into speckle mode, and then we'll manually take about 10 images. Now we need to open VIC 3D from the start menu. Then we go to Project, Calibration Image Groups. Make sure we have the correct folder selected, and it will give us the option of selecting the Cal images or the SPL images. The calibration images were obtained in calibration mode, whereas the SPL images were the last ones we just took of the specimen. For now, we want the calibration images. Click on the little vernier caliper doohickey to set up our calibration. Imaging system should match what was on the lens box, in our case Order 1. The target is 12mm. Press Analyze. After some time, the software will analyse all the cal images and presents a score. This score needs to be under 0.1, however I prefer to use 0.05 as a target score. You'll notice some images with poor scores, which could be due to motion blur or lighting issues on specific images or bad dots like this one over here. Without going into the specifics, just remove the red scores by right clicking and removing the row. Keep doing this until all of the red rows are gone. There should still be plenty of images left after doing this, and if not, you've done something wrong. After hitting accept, the system is calibrated and we can save and leave here. However, we'll do one final act, which is to add the hybrid cal. Go to Project, Speckled Image Groups, and import the SPL images out of the correct folder again. Use Draw Polygon under the AOI tools and draw the shape of the specimen in order to define the area of interest. You can use this opportunity to remove areas of no interest as well, such as the holes. Hit the green arrow in order to start processing the data. In the following box, there's only two items you really need to know about. One is to make sure that auto plane is set to on, and the other is to verify that strain is set to the engineering tensor. Press Run to calculate. Note the projection error score here. This must be less than 0.1. Go to Calibration, Hybrid Stereo System Calibration. Set the point limit to 4K or 8K, doesn't really matter, and then run this. This improves the calibration by utilising the specimen calculations within the calibration. Recalculate the specimen again, and you'll notice that the projection error has reduced significantly. Accept the cal, then save the project. Name it as a calibration project and close VIC 3D. And that's method 1, which will be perfectly adequate for 90% of work. This second method is a little bit more involved, but is applicable for when the calibration plates are too small for the field of view or some other problematic setup. We'll start off by giving ourselves a new folder to keep our new cal images in. Yes, I want to create that path. Next we'll take some cal images again. For the sake of argument, just imagine I didn't take these simultaneously, but you get the idea. The trick to it comes now. A quick brightness adjustment, and we'll take a couple of speckle images for the purposes of the cal. I'm going to give them the prefix hybrid, as these images will also help with the hybrid cal later on. A quick side note here, 2 marks have been placed in this specimen exactly 100 mils apart here. This is important, and your reference image must similarly have 2 marks present with a known distance between them. As per normal, we'll import the images as a calibration image group. Where we're going to change though is I'm going to calibrate camera 1 separately. Again, we'll have to change our imaging system and cal target to suit. Good score there for camera 1, so let's do the same thing for camera 2. Next we'll want to calibrate the camera orientation. This will generate an error message saying that we need a reference image, so we'll use one of our hybrid images for this. As per normal, import as a speckle image group. Trying to run the orientation cal will generate a different error now, as it wants some calculated data to work with. Define an area of interest and calculate. Doing so will generate this message. The answer is yes. Hit the run button and then this image will generate. Close the window and then finally we can run our external orientation calibration. For this part we need to know the exact distance between 2 points on our reference image. These 2 points are 100 mils apart, so I'll tell the software that. If we hit calculate, then the calibration result is given. Again, this must be under 0.1, but ideally less than 0.05. Accept this, and then as a final step we can also run our hybrid calibration as per earlier. And with that, we're ready for measurement. Just don't touch the cameras.